Hi guys, welcome to Thursday, March 19th. Today's AP Stat lesson will not involve homework. Happy day for you. I did post the answers to last night's homework, and hopefully if you had any questions, you already would have seen the key and asked me, but if you still need something done out, let me know and I'll post a video that explains the answers. For today though, I'm just going to give you another example of the two proportions confidence intervals. And here's how it's going to start. Ready? Here's your story. We take a random sample of 80 freshmen and 90 seniors, and we ask them the question, do you like this online learning that we have to do now? Of the survey respondents, let's say that 52 freshmen said, yeah, we like this. And that 72 seniors said, yeah, we like this. We want to find out if there is a significant difference between the proportion of freshmen and the proportion of seniors who enjoy this online learning experience. We want to do that with a 90% confidence interval for the difference. All right, well, let's begin. What are the conditions we have to verify to make sure that we can actually run this? Well, let's write them up. So the conditions, as usual, we have to have randomness. So I told you in the prompt that we have a simple random sample of freshmen and a simple random sample of seniors. So that actually works for both random samples. The 1/10 rule is our sample size no more than 1/10 of our population. Well, the population of freshmen needs to be at least 10 times as big as the size. I said there were 80 freshmen in the survey, so at least 800 freshmen. Obviously, there's not at least 800 freshmen in our school, but are there at least 800 freshmen anywhere that we could ask? Yeah, there are. We also want to verify that the sample of seniors was at least 10 times, well, at least 1/10, no more than 1/10 of our population. I asked 90 seniors, so I'm looking for there to be at least 900 seniors in the population of all seniors possible. And again, there are. Okay. The other condition is for our NP hat of freshmen, NQ hat of freshmen, NP hat of seniors, and NQ hat of seniors to all be at least 10. Well, how many freshmen said yes? I believe that was 52. Leaving how many freshmen to say no? There were 80 asked. So 28, almost a 27. Now, how many seniors would that give us who said yes? I said 72 said yes. Of the 90, that leaves 18 to say no. Now, all of those are at least 10. The condition has been verified. Okay? So far, so good. The conditions allow us to move forward, as pretty much every time we check conditions, it allows us to move forward. Yesterday, I gave you guys a little, organizer for your work. So I want to make a little grid that organizes the data we just collected. Okay. Now, because of spatial limitations, I'm going to erase what I just wrote, but please understand the conditions were necessary. And now I'm going to put on my little table. Now I'm going to have two samples, all right? I have freshmen and I have seniors. I need to know the sample size, those who said yes, the proportion of success and failure for each one. So far, makes sense, I hope. Now I said I asked 80 freshmen, and of them, 52 said yes. 52 divided by 80 is 65%, which leaves 35% who said, no, we don't like it. Of the seniors, we had 90 who were asked, and 72 said yes. 72 divided by 90 is 0.8, which leaves 0.2 for Q hat. The reason why this is useful is because we have to plug in values into our equation for confidence intervals, and this just makes it easier. Here's the equation again. P hat of the first, this time it's freshman, minus p hat of the second, seniors, plus or minus critical z times the square root of p hat of freshmen, q hat of freshmen over n of freshmen, plus p hat of seniors times q hat of seniors over n of seniors. You don't have to write that every time, obviously. I'm doing this because it helps to illustrate what we're doing. You could just jump into the substitutions. Okay, so here's what I get. I get 0.65 minus 0.8 plus or minus critical z-score for 90% confidence, because that's what I said we're going to use, is 1.6449. Square root of 0.65 times 0.35 over 80 plus 0.8 times 0.2 over 90. Okay, simple substitution, no problems there. If you continue the evaluation here, that's negative 0.15 plus or minus 1.6449 times the standard error, which turns out to round as 0.068. When you rounded it to 4, actually rounded off to 3. That gives us negative 0.15 plus or minus our margin of error, which is 0.1119. When you subtract and add, you get an interval of negative 0.2619 to negative 0.0381. What does this mean? Here's a sentence. I don't think I'm going to write it down, though. You should. We are 90% confident that the true difference in the population proportions of freshmen and seniors who enjoy online learning is between negative 0.2619 and negative 0.0381. Entirely negative. Think about that for a minute. I'm 90% confident that the difference between them is entirely negative. Well, that would only happen if seniors' proportions were significantly higher than freshman proportions, because that would yield an entirely negative interval. The number 0 is not contained in the interval. This is giving us some important information. It tells us that the difference between them is significant. Understand that. The 90% confidence level told us we're pretty darn sure there is an actual difference between these two populations. The shortcut double check. Take out your calculator. Now, like everything else, you want to go to your stat and then your tests menu. This one is the 2 prop z interval. Well, probably, either which way you go, up or down. 2 prop z interval is the B choice in my calculator. You guys like my new calculator? I just bought it. Now, it gives me options. It says X1, N1, X2, N2, level of confidence. Well, my first sample was freshman, and the X was 52, and the N was 80. 52 out of 80. The seniors had 72 out of 90. So 72 and 90. My confidence level is 0.9. I want a 90% level of confidence here. And what do I get? I get the answer. And it looks pretty darn similar to what we just came up with. Negative 0.2618 to negative 0.0382. It's off by the 10,000ths place because we rounded, the calculator did not, and that's fine. But again, we recognize that 0 is not contained in this interval anywhere. That's the shortcut. That's the method. It's pretty much all there is to this. I'm not going to give you homework, like I said, but please do the test if you didn't already. A lot of you did, and that's awesome. Thank you so much for that. Do the practice problems in the textbook if you didn't already. Use the answer key I posted online. Obviously, that's for you to double check your answers. Ask me questions if you have them. I hope everything's going well. I hope this is working out for you. I like your comments. Thank you very much. It's funny. I appreciate it because I'm also in a bit of a quarantine myself, and I don't mind some interaction too. Hope all is well. I hope to see you soon. Take care.